Okay folks, solutions to the resistors in parallel example. So again, first thing that we were asked to do is work out the total resistance, and we know here that 1 over RT is 1 over R1 plus 1 over R2. So we've got 1 over RT equals 1 over 9 plus 1 over 15. And if we add all those together and do all our maths that we have to do, we end up that 1 over RT is the same as 1 over 0.1777 and many more 7s. Which leaves us to RT equals 5.62 ohms. The total resistance of this circuit is 5.62 ohms. Please note that that is smaller than either of those resistances. It's smaller than the 9 ohms and it's smaller than the 15 ohms. The next one is working out the current drawn from the power supply. We just do this exactly the same way that we did in the previous example. We use V equals IR. We know that V is 12 volts. We now know that R is 5.62 volts. So we have 12 equals I times 5.62. So I, again, V divided by R becomes 12 over 5.62, which gives us 2.14 amps. Again, so far, so simple. Now, you might think that working out the voltage across the resistor and the bulb is going to be very difficult now. But it's actually the easiest part of this question. Now, the last time when we were doing this with series circuits, we had to remember that the current is the same everywhere in a series circuit. Now, what we have to remember this time is that the voltage in each path of a parallel circuit is the same, and it's going to be the same in this case as the supply voltage. So because our supply voltage is 12 volts, and we know that the supply voltage is the same as V1 is the same as V2, then the voltage across the resistor is going to be 12, and the voltage across the bulb is also going to be 12 volts. There we go.